Hello everyone, I'm Abhishek from Minerva and today we are just going to continue the previous topic, that is the convex mirror. So in the previous class we had completed the topic that is of concave mirror. Now this is the new topic, but the diagram, the ray diagrams and the total characteristics of this mirror we are just going to analyze in today's class. So let's start that. What is convex mirror actually? Convex mirror will look like this, and in this case this will be the reverse form of that concave mirror. So in that case the reflecting surface will be the outward surface of that. That means the outward portion of this mirror will act as a reflecting surface, right? And the inward portion will be silver coated. That means the light cannot pass through that portion, right? So in that case we will just identify the same things, that is the pole, focus, the radius of curvature, the center of curvature and the principal axis. We will identify each and everything. So at first what you should have to do, that is, this is about your total linear aperture. So the midpoint of this linear aperture, that will be your pole, right? So in this case I can identify that this should be the pole, so it can be represented by P, right? So it can be represented by P, and this is one type of spherical mirror. So about this spherical mirror, it should have some center. So the center of that spherical mirror should be known as center of curvature, right? The center of that spherical mirror, it may be a convex or it may be a concave, that center is known as center of curvature. So if you join this pole and center of curvature, it will form an axis, and we know that what's the name of this axis? This is known as a principal axis. And in this case the midpoint of this pole and center of curvature is known as focus. It is represented by F, right? And the center of curvature you can represent by C in this case. Now why we are telling that the midpoint of this pole and center of curvature will be the focus? Because I will do the analyze for the case of convex mirror at first, then I will tell you the reason for the case of concave mirror as well. Because as we know that convex mirror is one type of diverging mirror. Why it is called a diverging mirror? Because if the parallel rays are coming to that of surface, if the parallel rays are coming to that of reflecting surface, then what will happen? They will be reflected like that. That means this is the incoming ray, this is the incident ray, and this should be the reflected ray. For each and every cases, this should be the reflected rays. That means they are not able to meet at any of the points. That means they are not able to form an real image, but they appears to meet at a point. That means at the reflecting point, at this point of reflection, if we just extend this lines, they will appears to meet at a point that is known as a focus. That's why we tell that the focus can be identified when some parallel beam of light are incidenting on the reflecting surface, and after the reflection, if they appears to meet at a point, that point is known as focus. Now, the distance of the pole and the center of curvature is known as a radius of curvature, right? And in this case, this is known as the focal length. And what the relation we had understand in the previous class, that the radius of curvature is equals to twice of the focal length, right? Or we had written that focal length equals to radius of curvature divided by the 2. So these two relations we have just drawn from the previous analysis. Now, as when the parallel beam of light are coming to that of reflecting surface and they are just reflected like that, so they are not meeting at any of the points, so the rays after the reflection, they are diverged. So that's why the mirror is called the diverging mirror. The convex mirror is the diverging mirror. We will analyze for the case of concave mirror as well. So if I just draw a figure of concave mirror like that, suppose this is our concave mirror whose outward portion is silver coated and the cave portion is used as a reflecting surface. So this is the midpoint of this linear aperture. It is known as a pole, and there is a center. We are assuming that this spherical mirror is a part of a sphere, so that's why it is the center. It is known as the center of curvature. If we pass a line through them that will join the center of curvature and the pole, it will form a principal axis. In that case also, this is the principal axis, right? This is the principal axis, and in that case also, this is the principal axis, right? Now, what is the midpoint between center of curvature and pole? That is the focus in this case. Now, why I am telling that this should be the focus, that is the midpoint of center of curvature and pole? Because when parallel beam of light rays are coming towards the reflecting surface, then what will happen that after the reflection, they will just meet at a point, right? After the reflection, they will just meet at a point. So I can say that they will form a real image, because if the parallel beam of light rays are coming on that surface, that reflecting surface, so after reflection they are just meeting at focus. So at focus they are just forming an image. That's a point image, a very small size of image. But in the case of a convex mirror, what happens? They doesn't meet at a point. They appears to meet at this point, that is known as a focus. So in the case of convex mirror, we always get the virtual image. But in the case of concave mirror, in maximum of cases, we get the real image, except one case that I will explain, that in which case you will get the virtual image for the case of concave mirror. This is the portion of concave mirror. Let me write it down. This is the portion that of concave mirror that we have completed till now. So I hope it is understandable for two of the cases that why we are just telling that convex mirror is one kind of diverging mirror, and the concave mirror, as you know, this is one type of converging mirror. Now the next thing that we have to form the different kind of ray diagrams. Ray diagram means, suppose a source, energy source or a light source is placed on the principal axis of a mirror, and from that source some parallel beam of light rays that will come and that will reflect over that reflecting surface, and for that we will get the image. तो फिर अब हम बात करते हैं रे डायग्राम्स कैसे बनाना होता है. रे डायग्राम्स बनाने के लिए क्या चाहिए कि आपको कोई भी मिरर आपको दिया जाए, इट मे बी अ कंकेव मिरर और इट मे बी अ कन्वेक्स मिरर, आपको कोई एक सोर्स को प्रिंसिपल एक्सिस के ऊपर रखना है और उसकी वजह से जो डिफरेंट रेज प्रोड्यूस होते हैं आफ्टर द रिफ्लेक्शन, उसकी वजह से कैसे इमेज बनता है वो हम लोग सीखेंगे. लेट्स स्टार्ट. Now, before proceeding to the ray diagrams, we should know some of the basic rules so we can form the ray diagrams better. So, for the case of concave mirror, and for the case of convex mirror as well, we have some basic rules that we'll study for the case of ray diagrams. So, if this is our concave mirror, so the outward portion of that will be coated. This is your pole, and suppose this is your center of curvature, and we are just drawing the principal axis. This is the focus. Okay. In the case of convex mirror also, we are just drawing the ray diagrams. Now the basic principle says that this is the pole, this is the center of curvature, and through them if I pass an axis, this should be the focus, right? Now the first rule that it says that if parallel beam of light rays coming on that reflecting surface of the concave mirror, if a parallel beam of light or if some parallel beam of light rays are coming on the reflecting surface of the concave mirror, then after reflection they will obviously pass through the focus. The first thing you have to remember, right? So in the case of convex mirror, what will happen that if a parallel beam of light rays are coming on the reflecting surface of the convex mirror, then after reflection it will move like that. But that means they are not meeting the focus directly, but they appears to meet. That means the light ray appears to pass through the focus. This is the first rule for both of the mirrors, that in the case of concave mirror, if a parallel light ray or some parallel light rays are coming, then after reflection they will pass through the focus. And in the case of convex mirror, if some parallel beam of light rays are coming on the reflecting surface, then after reflection the ray will reflected like that. That means that if I extend the reflected ray, then they will appears to meet at the focus, right? Second thing, that means in every of the cases we have 3 cases. For 3 cases we have to just make the diagrams. The next case, that is, again we are just making that of diagrams. I am just making diagrams quicker. There is the pole, there is the center of curvature, and that is the focus. And in that case of convex mirror also, I am just making the diagram more fast. So this is the pole, this is the focus, and this is the center of curvature. So in that case, the second rule, that is the reverse rule of the first. That means if the light rays are coming through that of focus, and they are incidenting on the reflecting surface of the concave mirror, they will be parallel to that of principal axis after the reflection. So in the case of convex mirror as well, if the light rays are coming towards the focus, so after the reflection it will be parallel to that of principal axis. This is the second rule for both of the mirrors. This is the concave mirror and this is the convex mirror. So in the case of concave mirror, what I have seen, that if a light ray is being passed through the focus, then after reflection it will go parallel to that of principal axis. And in the case of convex mirror, if a light ray is coming towards the outward portion, that is the reflecting surface of the convex mirror, so after the reflection it will pass in parallel with that of principal axis. तो इसके बाद आता है थर्ड रूल, जहां पर हम कंकेव मिरर और कन्वेक्स मिरर दोनों को देखेंगे. नाउ अभी हम लोग बताने जा रहे हैं थर्ड रूल. थर्ड रूल में क्या है कि अगर आपके पास एक कंकेव मिरर रखा हुआ है, कंकेव मिरर का डायग्राम थोड़ा फास्ट बना रहे हैं हम, तो दैट विल बी योर फोकस. तो अभी हम लोग कंकेव मिरर का थर्ड रूल जानेंगे रे डायग्राम्स बनाने के लिए. तो अगर ये आपका कंकेव मिरर है, जहां पर ये आपका पोल, दैट इज योर सेंटर ऑफ कर्वेचर एंड दिस इज द फोकस, राइट. तो इसमें क्या करना है आपको, अगर मान लीजिए कि आपका कोई भी एक लाइट रे आपका सेंटर ऑफ कर्वेचर के थ्रू रिफ्लेक्टिंग सरफेस पे आ रहा है, कोई भी एक लाइट रे अगर ऐसे सेंटर ऑफ कर्वेचर के थ्रू रिफ्लेक्टिंग सरफेस की ओर आ रहा है, दिस इज द डायरेक्शन ऑफ द इंसिडेंट रे, सो आफ्टर द रिफ्लेक्शन इट विल पास इन द सेम पाथ. दैट मीन्स अगर कोई लाइट रे सेंटर ऑफ कर्वेचर के थ्रू, नाउ वी आर जस्ट मेकिंग द थर्ड रूल, दैट इज इफ देयर इज द कंकेव मिरर, that the outward portion is silver coated and this is the midpoint, that is the pole, and through that pole you are just passing the principal axis. This is the center of curvature, this is the focus. Now in that case the third rule says that अगर आप center of curvature के through कोई light ray pass करते हैं and that will incidenting on the reflecting surface, that is incidenting on the reflecting surface of concave mirror, then the light ray will comes back through the same path. That means जिस रास्ते से वो गया था reflecting surface के ऊपर, उसी रास्ते से वो वापस आएगा. The same rule happens in the case of convex mirror as well. Now this is the convex mirror, right? Suppose we are assuming this is the pole and through that pole we are just passing the principal axis again. So this is the center of curvature and that is the focus. In that case also, if some light ray is incidentating with respect to the center of curvature, the light ray will comes back to that of same path. That means अगर कोई light ray reflecting surface के ऊपर आ रहा है कुछ इस तरीके से, मतलब वो center of curvature के थ्रू पास होना चाहता है, then the light ray will be reflected back in the same way. So this is the third and the last rule. तो ये सारे रूल्स जानने का फायदा ये है कि अगर आप रे डायग्राम्स बना रहे हैं तो रे डायग्राम्स में कोई एक लाइट सोर्स आप यूज करेंगे, तो उस लाइट सोर्स से डिफरेंट काइंड ऑफ रेज निकलते हैं. तो उन रेज को रे डायग्राम्स जानने का फायदा ये है कि अगर आप रे डायग्राम्स बना रहे हैं कंकेव मिरर के लिए या फिर कन्वेक्स मिरर के लिए, देन इन दैट केस व्हाट विल हैपन, आपको रे डायग्राम्स बनाने में आसानी होगी. you will know that if the parallel beam of light rays is incidenting on the reflecting surface, then what will happen? If the light ray is want to pass through that of center of curvature, then what will happen? So it will help you out to making the ray diagrams. So let's start the ray diagrams for the case of concave mirror. Now we are just going to analyze the images formed by that of concave mirror. So in the case of concave mirror, at first we should construct the mirror. So suppose this is your mirror, and in that case the outward portion will be silver coated. This is the middle point of that of linear aperture. This is known as pole, and through that pole I will pass the principal axis. So this is the center of curvature we are assuming, and in that case this is the focus. So the first point we are just going to analyze कि अगर आपका ऑब्जेक्ट इन्फिनिटी पे रखा हुआ है, कोई एक लाइट सोर्स जो इन्फिनिटी पे रखा हुआ है. इन्फिनिटी का मतलब ये नहीं है कि आप दूर चले गए इन्फिनिटी को ढूंढने के लिए. इन्फिनिटी मतलब ये जो मिरर है, मिरर का जो रेंज होता है, रेंज के कुछ बाहर अगर कोई लाइट ऑब्जेक्ट रखा हुआ है तो वो ऑब्जेक्ट से जो लाइट रेज आ रहा है, हम लोग मान लेते हैं कि वहां से पैरेलल बीम ऑफ लाइट रेज ऐसे आ रहा है और वो मिरर का जो रिफ्लेक्टिंग सरफेस है उसके ऊपर आके रिफ्लेक्ट हो रहा है. सो आफ्टर द रिफ्लेक्शन देन व्हाट विल हैपन? दे विल मीट एट द फोकस, राइट? After the reflection, that what will happen, that they will meet at the focus, so they will make a point image. So अगर आपका ऑब्जेक्ट इंफिनिटी पे रखा हुआ है, मतलब ऑब्जेक्ट प्लेस्ड where object placed at infinity, image formed, image कहाँ पे बन रहा है आपका? Image is formed at the focus. Type, what's the type of image? It's of point size image, right? We are just getting a point size image at the focus. So यही वाला रे डायग्राम से हम लोग मिरर का कन्वर्जिंग प्रॉपर्टी को भी डिस्क्राइब कर सकते हैं और इस वाले प्रॉपर्टी को भी डिस्क्राइब कर सकते हैं कि अगर आपका ऑब्जेक्ट इंफिनिटी पे रखा हुआ है, अगर वो एक ल्यूमिनस ऑब्जेक्ट है, तो वहां से जो लाइट रेज आ रहा है तो वो लाइट रेज आफ्टर द रिफ्लेक्शन दे विल मीट एट द फोकस. So we are just getting a point size image at the focus. So these 3 points you have to just remember, that the object placed at infinity, we are getting the image at the focus, and the type of image that is of point size. Now we are just moving to the next case, that is अगर ऑब्जेक्ट इंफिनिटी पे ना रखा हुए, अगर ऑब्जेक्ट आपका सेंटर ऑफ कर्वेचर के बाहर रखा हुआ तो उसमें आपको क्या करना है कि अगर आपका ये मिरर है जिसका आउटवर्ड पोर्शन सिल्वर कोटेड है, दिस इज द मिड पॉइंट, दैट इज द पोल, थ्रू दैट पोल आई एम जस्ट पासिंग अ लाइन, दैट इज द प्रिंसिपल एक्सिस, दिस इज द सेंटर ऑफ कर्वेचर एंड दैट इज द फोकस. सो वी आर जस्ट प्लेसिंग दैट ऑब्जेक्ट आउटसाइड ऑफ दैट सेंटर ऑफ कर्वेचर. तो आपने एक ल्यूमिनस ऑब्जेक्ट को सेंटर ऑफ कर्वेचर के बाहर रखा है, तो यहां से लाइट रेज आएगा. पहला लाइट रे जो आपका प्रिंसिपल एक्सिस के पैरेलली जाएगा. अगर कोई लाइट रे आपका प्रिंसिपल एक्सिस के पैरेलली जाता है तो आफ्टर रिफ्लेक्शन इट विल ऑब्वियसली पास थ्रू द फोकस, राइट? देन द सेकेंड थिंग, दैट इफ द लाइट रे passes through the center of curvature, then what will happen? If the light ray is coming through that of center of curvature, जिस रास्ते से वो, अगर वो सेंटर ऑफ कर्वेचर के थ्रू पास हो रहा है, जिस रास्ते से वो रिफ्लेक्ट होने के लिए गया था उसी रास्ते से वो वापस आएगा. And at the intersecting point we are just getting an inverted image, right? At the intersection point of these two light rays we are just getting an inverted image, and that is also small in size. So that's some of the things you have to remember in this case. These 3 things, that object, position of object, you can say object was placed at beyond center of curvature, beyond center of curvature. If the object is placed beyond of center of curvature, we are just getting the image in between center of curvature and focus. So image we are just getting between center of curvature and focus. I'm just writing in short that we are just getting the image between the center of curvature and focus. And the type of image, what's the type of image? It is an inverted image, right? It is an inverted image and small in size. It is also small in size. So in this way we are just going to analyze each of the ray diagrams. Now we are just proceeding for the next. Now we are just going to analyze the third case, right? Now this is our concave mirror, In that case, we are just making that same diagram over here. This is the pole. Through that pole, we are just passing the principal axis. This is the center of curvature, and that is the focus. In the last case, we have just placed that object beyond the center of curvature. Now we are just placing that object on the center of curvature. So you are placing that luminous object on the center of curvature. So let's see what will happen. That the light rays will pass parallel to that of principal axis, and after the reflection they will pass through the focus, right? And the next thing, that if the light rays are passing, it's just directly just passing through that of focus, then what will happen? If the light rays are going through that of focus and they are incidenting on the reflecting surface, so after the reflection they will be parallel to that of principal axis. Mirror ray diagrams देख के तो लगता है it is not being parallel, but you can say if it is a straight line, it should be a parallel. Now, at the intersecting point of that, we will get an inverted image and that will be of same size. अगर आप कोई ऑब्जेक्ट को सेंटर ऑफ कर्वेचर पे रखते हैं तो उसकी वजह से जो इमेज आपको मिलेगा दैट शुड बी अ इन्वर्टेड इमेज एंड इट विल बी ऑफ अ सेम साइज. उसके लिए देखिए, आप हमने जो इमेज को रखा था वहां से दो रेज निकला है. पहला रे, अगर आपका रे पैरेलली जाता है तो रिफ्लेक्शन के बाद फोकस के थ्रू निकलेगा, और इसका रिवर्स, अगर वो फोकस के थ्रू जाता है तो रिफ्लेक्शन के बाद पैरेलली निकलेगा. अब दोनों जहां पे इंटरसेक्ट किया है वहीं पर हमको इमेज मिला है, राइट? एंड दैट्स एन इन्वर्टेड इमेज एंड इट इज ऑफ अ सेम साइज. So let's write down what you know, that the object कहाँ पे placed किया था? At center of curvature, right? At center of curvature. And image कहाँ पे मिला हम लोगों को? At center of curvature, same. I'm not writing down the center of curvature again. I hope you have understood. So object and image दोनों हमको same जगह पे मिला है. What about the type? The type of image we have got over here, that will be of inverted image, and it is of same size, right? The image is of inverted image and it is of same size. Now, अगर हम ऑब्जेक्ट को इसके नेक्स्ट वाले रे डायग्राम में, if we just place that object between that of center of curvature and focus, let's see that how the image can be formed. So in the next ray diagrams, what we'll do, we'll just make a concave mirror again, and this is the pole as we know. So the P can be placed here, and through that pole, if we just pass a principal axis, this is the center of curvature, that is the focus. Now we are just having the next case where we are just placing that object in between that of center of curvature and focus. तो अगर हम ऑब्जेक्ट को सेंटर ऑफ कर्वेचर और फोकस के बीच में प्लेस करते हैं, and it's a luminous object, then obviously the light rays will emit from it and it will pass like that. That is parallel to that of principal axis. And after the reflection, it will obviously pass through that of focus, right? अगर कोई luminous object को अगर आप center of curvature और focus के बीच में रखते हैं तो वहां से जो parallel light ray निकलेगा वो after reflection focus के through जाएगा. Now the second light ray, that is if the light ray is incidenting on the upper portion of that linear aperture, then what will happen? It will comes back in the same way and they will meet like that. They will meet like that. I'm just making that of diagram straight so you can form that of image. They will pass through that of, if the light rays is incidenting on that of upper portion of that linear aperture, it will comes back in that of same way and it will pass through that of center of curvature. And these two light rays will intersect and it will form an image that will be of inverted image, but in this case this is of greater in size. That means the image will be enlarged. So what can we write down over here? That is the object is placed between C and F. Between C and F the object was placed and we are just getting the image. We are just getting the image beyond of center of curvature, right? So we are getting the image beyond C. C for center of curvature. Now the type of image. What's the type of image we are just getting? That the image is of inverted in nature and it is enlarged in size. Object का जो size होगा उस size से बड़ा होगा. If you are placing that object between center of curvature and focus. मतलब center of curvature पे जहाँ पर हम लोगों ने पिछली बार ऑब्जेक्ट को प्लेस किया था वो लास्ट था जहां पर ऑब्जेक्ट का साइज और इमेज का साइज सेम था, राइट। तो सेंटर ऑफ कर्वेचर से जैसे आप आगे बढ़ते जाएंगे इमेज का साइज बड़ा होता जाएगा एंड फाइनली इट विल रीच एट इंफिनिटी, राइट। दैट विल एनालाइज इन द नेक्स्ट केस. So we are just moving to the next case, that is the fifth one. So in the fifth case, what the case will analyze, that this is our concave mirror, and in that case we are just making the mirror at first. So that's why we are just identifying each of the components over here. So this is the center of curvature, this is the focus, and this is the pole, right. Now you are just placing that object on the focus. So what will happen if you are placing that object on that of focus? Then some light rays will emit from that of luminous object. One of the light rays that will incidenting on that of reflecting surface parallel with respect of principal axis. अगर वो parallelly reflecting surface के ऊपर आ रहा है, so after the reflection it will obviously pass through that of focus. We know the basic rule, right? And the second light ray that is incidenting on the topmost portion of the linear aperture, and it will pass through that of center of curvature. So according to the ray diagram, what is happening, if you are placing that object in that of focus, you are getting the image at infinity. That means आपको जो image मिलेगा that will be of large in size, but it will be at infinity. So the image we are just getting, that is of inverted in nature, it is of enlarged in size when you are placing that object in focus. Now in this case we are just writing down all of the things that we write for every cases. Object is placed at focus, right. We are getting the image at infinity. That means infinity is where? Infinity is beyond the range of that mirror. That means at this portion you are just getting the image. If you are placing the screen at this point, because in every of the cases till now you are getting the real image, that means you can place that image in the screen. So if you place that screen beyond the range of that mirror, you can obviously see that the image is of large in size and it is inverted. Now what's the type of image we are just getting? That is inverted in nature and enlarged. Okay. Now we are just going to analyze the last case, जहाँ पर हम देखेंगे कि concave mirror virtual image कैसे form कर सकता है, right? For that case, what you have to do, we have to make the ray diagrams at first. For that case, I'm just making the concave mirror. This is the pole, this is the center of curvature, and that is the focus. Now you are just placing that object in between that of pole and focus. So what will happen? The same thing happens obviously. So in that case, the parallel light ray, one of the light ray that is parallel to that of principal axis, is incidenting on that of reflecting surface of that mirror. Then after the reflection, that what will happen? It will pass through that of focus like that. And another thing that will happen, that another light ray that is incidenting on the topmost portion of the linear aperture, and after the reflection it will pass through that of center of curvature. That means हम लोगों ने क्या किया कि ऑब्जेक्ट को फोकस और पोल के बीच में लाया, राइट? तो उसकी वजह से क्या होगा कि आपका जो इमेज इन्फिनिटी पे बनता था, अब वो इन्फिनिटी पे आपको रियल इमेज देखने को नहीं मिलेगा. You will get an image behind of that mirror, and that is a virtual image. That means the image you are just getting, that is not produced due to the meeting of the light rays. That is, the image is produced when the light rays appears to meet at a point, and in this case only you are just getting the virtual image. In this case the image is a virtual type and it is obviously enlarged. That means it is larger with respect to the size of the object. So in that case also we are just writing down the data that the object is placed between focus and pole. You are just getting the image at where? Behind of mirror. Behind of mirror you are just getting the image, and the type of image. The type of image is, it is erected, right? It is not inverted, it is erected, and in that case it is a virtual in nature, right? So in this way we can complete all of the ray diagrams with respect to that of concave mirror. Now the next job is you have to just make a table, thus you can remember each and every cases and all. The first thing you have to just keep in mind, if you are placing that object on infinity, you are just getting the image at focus, and if you are just keep moving the object from left to right, that means the object size, the image size is increasing. If the object is being placed, that means if the object is moved from the left side to the right side of the mirror, that means the image size is increasing, and in between that of pole and focus, it is maximum. That's the case of a virtual image. Now we are just making a table, thus you can remember all of these things in a gist. So now we are just going to make a table, that is, we have just made that column, that position of object, position of image, size of image, and nature of image. So initially, where we have placed that object, we had placed that object at infinity, right? We had placed that object at infinity and the position of image at focus. The size of image was of a point size. A point size image we had just got. Nature of the image, that's a real image. You can say it's a real and inverted. Though for the case of point size image, it cannot be judged that it is inverted or not, but the property says that it should be real and inverted. Now in the next case, we had placed that object at beyond of center of curvature. When we are placing that object beyond of center of curvature, we are just getting the image, at between center of curvature and focus, right? So obviously the image what we have get, that is of small in size, right? It is of small in size, and that's also real and inverted, right? Now this is the third case where we have placed that object at C, that means the center of curvature. If you are placing that object at center of curvature, you are just getting the object at C, at center of curvature. The object is of same size, sorry, the image that is of same size that of object, and in this case the nature of the image, that will be real and inverted, right? The nature of the image, that is same. Now after that, after that C, that means after that center of curvature, you have to place that object between center of curvature and focus. If you are placing that object between the center of curvature and focus, you obviously get the image beyond of C. That means these two are just reverse. If you are placing that object beyond of C, you are getting the image between center of curvature and focus, and if you are placing that object in between center of curvature and focus, you are getting the image beyond of center of curvature. In this case, after you are just covering that of center of curvature, that means the object is placed after center of curvature in between C and F, that means center of curvature and focus. So in that case, after crossing the center of curvature, the image size will be increased. That means it will be a enlarged image will be formed. Enlarged image you will get, and that will be obviously real and inverted, right? That will be of real and inverted. Now in the fifth case, where it is placed at focus. At focus, if you are placing, so you will get the image at infinity, right? You will get the image and infinity. So at infinity you will get the largest image by that of concave mirror. So it is largely enlarged, you can write down. It is largely enlarged. Highly enlarged will be better. So the image that should be of highly enlarged. That means if you are placing that object at focus, the image will be highly enlarged. That means the size of image will be greatest. Then all of the images formed in that of concave mirror. If you are placing that object at focus, you will get the image at infinity and it will be of highest in size. Now, the image is obviously real and inverted, right? In that case also. Now the last case we are just going to conclude. If you are placing that object between of focus and pole, if you are placing that object between the focus and pole, you will get the image beyond of mirror, right? You will get the image beyond of the mirror. In this case, what will be the size of that image? In this case, it will be enlarged you can say it will be enlarged, it will not be highly enlarged. Highly enlarged we will get in the case of focus only, right? Now, what will be the property? It will be a virtual and erected. So in this way we have covered all of the topics. That means if you are placing that object at infinity, you will get the image at focus. If you are placing at C, you will get the image at C and F. If you are placing at center of curvature, you are getting the same size of image at center of curvature. And now these two things are just reverse. You can see these two things, even these two things are also reverse. That means if you are placing an object at center of curvature, you are getting an image between center of curvature and focus, and the reverse is also true. If you are placing that object in between of center of curvature and focus, you are getting that image at C, right? And then in the last case, what we have concluded, that if you are placing that object between focus and pole, then you will get the image behind of that of mirror, and it will be enlarged in size. It will be a virtual image and it will be erected. It will not be inverted. So now we are just going for the next concept of convex mirror. We will draw two ray diagrams for the case of convex mirror. Now we are just starting the topic that the images formed by the convex mirror. Now for the case of convex mirror, at first we will draw the diagram of that. Now for the case of convex mirror, we know this should be the pole, and through that if we pass a straight line, it should be the principal axis of that. So this is the focus, that should be the center of curvature. If you are placing that object like that, so in that case it's a luminous object, so obviously the light ray that is parallel, that will incident parallel with respect of the principal axis, and after the reflection it will move like that. So what the properties we know, that if a light ray is incidenting on the reflecting surface of that of convex mirror, so after reflection if it is being passed like that, so it will appears to meet at the focus, right? So it will appears to meet at the focus. Now if a light ray is being projected like that, if a light ray is being projected like that, then in that case we know that if a light ray is hitting the linear aperture, the reflecting surface of that of convex mirror, if the light ray is incidenting on that, then it will pass on through the same way. That means if the light ray is incidenting on that of reflecting surface like that, it will be reflected in that of same way. And in that case, if we are extending that of, it will pass through that of center of curvature. So these two light rays are meeting at this point. So at this point we will just get our diminished image, and that will be of virtual and erected. So in this case we are just writing that the object is placed anywhere of the principal axis. So we are just getting anywhere of the principal axis, and obviously in the left side of the mirror the object is placed. So that's why we are just getting the object in between of that of pole and that of focus. In this case, object is placed on the principal axis, at any of the points in between. If you are placing that object, you will get maximum of the image are of same in nature. In this case, the image we are just getting between focus and pole, right? You will get the image between our focus and pole, and in this case the type of image, if we want to discuss, the type of image will be diminished in nature. The type of image that will be of diminished in nature, it is virtually erected, right? Obviously it's a virtual image because the light rays are actually not meeting at this point, they appears to meet at this point. So that's why you are just getting the image that is obviously virtual image, and it is erected in nature. Now if that happens, that if that object is placed at infinity, then what will happen? We had already discussed that point, but I am discussing that one again. So this is the convex mirror. Suppose this is the pole, this is the focus, that's your center of curvature. If the object is placed at infinity and it's a luminous object, then obviously the light rays will hit the reflecting surface of that of concave mirror like that. So after reflection, what will happen? The light rays will pass like that, right? They will diverge. but they appears to meet at that of focus. In this case, they appears to meet at that of focus. So what can I conclude? That if the object is placed at infinity, then we are just getting the image at focus, right? In this case, we are just getting the image at focus, and if I discuss the type of the image, that will be a point size image, right? It's a point size image. You can say it's a virtual image. And if the image has a very negligible height, then you can say it is virtually erected also. But for the case of point size image, it is very rare to decide that whether it is erected or not. So in this case, if you are placing that object at infinity, you are getting the image at that of focus. At focus, you are getting the image, it's a point size image. So in the place of type, we are just writing it's a point size image, it's virtually erected, right? In the case of convex mirror, you will obviously get all of the images that are virtually erected, and obviously it's a diminished size in nature that we have already written. It is a point size. That means if the object is having some amount of height, it is placed at infinity, you will obviously get the image that will be a point size. It's just a point, and you can say it is a virtually erected. Now we are just going for the case of sign convention of the mirror. For the concave mirror and for the convex mirror, the sign conventions that are taken with the help of a mirror formula. Now we are just going to start the next topic, that is of the sign conventions for the case of concave and convex mirror. So at first we'll just make the diagrams of that. This is the concave mirror, right? This is the pole, that's the center of curvature, this is the focus. Now the first confusion that every time comes on the student mind, there's for the case of concave mirror, what will be the object distance, what will be the image distance, it should be plus or it should be minus, how can we remember that? For that case, we have to understand this one very much. So in that case, that's very much simple. If you are confusing at the time of exam, just make a simple ray diagram. Now it's a simple ray diagram, it's just a concave mirror. If you are placing that object, suppose I am placing that object at a center of curvature. So I will get the image in the center of curvature, obviously. So all of the distances in the left side of the mirror are taken as negative. All of the distances on the right side of the mirror are taken as positive. If the image is formed in the case of concave mirror on the left side, then all of the distances are taken as negative. That means when the object is placed at center of curvature, the object distance will be measured with respect to that of pole, right? So in that case, this should be the object distance, right? So I can write down that the object distance should be of negative. And if you are placing that object at center of curvature, you will get the image at a center of curvature, right? That will be of same in size. So in that case, the image distance that will also be negative, because the image is formed on the left side of the mirror and that should be measured in negative sign. And the next part, that is of the focal length. The focal length should be considered in that portion where the images is formed. Now in this case, all of the images are formed on the left side of the mirror except the last one. When the object was being placed between the focus and the pole, except that case, maximum of the images by that concave mirror was being formed on the left side of the mirror, right? So in that case, the focal length for maximum of the cases except the last one will be negative. In that case, the focal length should be measured from that of pole. Every distance should be measured from that pole. Object distance, if you want to measure, that measure the distance from the pole. Image distance, just measure that from pole. The focal length, it will be measured from that of pole. So in that case also, the focal length will also be negative. So in maximum of the cases except the last one, I will discuss the last one separately. It's a special case. So in that of cases, in maximum of the cases of that of concave mirror, where the object is placed on the left side of the mirror and the image is also formed in the left side. So in all of the cases, the object distance, the image distance and the focus, all of them will be negative. So now we are just going to analyze the sign conventions for the case of convex mirror. So at first we should make the diagram of that of convex mirror. So now this is the diagram, this is the principal axis, it is the pole, this is focus, and this is the center of curvature. Now if you are placing that object, at some point you are placing that object. Now we are just going to analyze for the sign conventions for the case of convex mirror. So now for the case of convex mirror, at first we should make it. Now this is the convex mirror, this is the pole, that's the focus, this is the center of curvature. Now if you place any of the objects at this point, so you will obviously get a diminished image, right? So the image is formed on the right side of the mirror and you are placing that object on the left side of the mirror. So every distances on the left side of the mirror are taken as negative. Every distances on the right side of the mirror are taken as positive. So if the image is forming on the left side, on the right side of the mirror, so the focal length should be considered like that. This should be the focal length. So in this case, this should be the object distance, and the small distance, it is the image distance. What can I see? That the object distance is only negative in this case because the distance is measured in the left side of the mirror, but the image distance is positive as well as the focal distance is always positive in the case of a convex mirror. For the case of convex mirror, for every of the cases, the object distance should be negative, the image distance and the focal distance all are positive. So the sign conventions for the case of concave mirror and convex mirror we are just able to know. So if you feel uncomfortable, so you just eliminate this V sign over here. So for the case of concave mirror, all of the object distance, image distance and focus, these all are negative. But for the case of convex mirror, only the object distance is negative, but the image distance and the focal distance, these two are the positive in nature. Why? Because these two distances are measured in the right side of the mirror. Now what we'll do with that of sign conventions, we should know the mirror formula. What's the mirror formula? The mirror formula is 1 by V plus of 1 by U, that is equals to 1 by F. That is known as a mirror formula, right? With that of mirror formula, we will able to calculate. That means any of the two quantities will be given to us. Suppose the object distance and the focal length are given, we have to find out the image distance. Otherwise, the image distance and the object distance are given, we have to find out the focal length. And lots of cases are possible with that of mirror formula. So in that application of this, we should implement the sign conventions of these two mirrors, right? But before proceeding to that of numericals, we should know some of the things. Now in the case of concave mirror, we have seen that some of the images are magnified, some of the images are enlarged. Now if the height of the object is given to you and you are told to find out the image height, then how you will find out? You have to know that how much magnified the image is. That means you have to know the magnification. So there a new term that I am going to introduce over here, that the magnification for both of the mirror, the magnification formula that will be same. That I am just making a small section over here to write down the formula for magnification, that is equals to minus of V by of U. What is V? V is the image distance, U is the object distance. Let me write down that it is of minus of image distance divided by of object distance, right? So this is the formula for the case of magnification. Magnification equals to minus of V by U. Now what I have asked you, that you have to find out the image height. So there should be another formula for the case of magnification. Now the magnification have two formulas. Another formula that I can write down, that now in the previous case what we have learned, that the magnification is having the formula that is of minus of V by U, that is of minus of image distance divided by the object distance. Now we are having another formula that is of HI divided by of HO. That is HI, that is of image height, right? It is actually the image height that we have to determine, and H of O, this is actually the object height that will be given to us in maximum of the numericals. The object height will be given to us, that a 2 cm small object is placed in front of 15 cm of a concave mirror or convex mirror. The focal length will be given, you have to find out the image distance, and after they will ask you that find out the magnification, then find out the image height. So in that case we should use this formula. Now this formula can be broken down. That means magnification, that is of minus of v by u. You just find out the value of magnification, then you just write down magnification equals to hi by hu, then you place the value of magnification over here and you will get the image height from that, right? So let's understand that concept with the help of one numerical. Now in this case we are just discussing about an example that I have drawn, a pictorial example, right? Now that type of question will not be asked in your exam, but this is the first numerical that we are going to do, so that's why I have just drawn a ray diagram over here. Now in this case, at first you have to recognize that which of the distances are given to you. In this case the object is placed beyond that of center of curvature, so obviously this is the object distance, that is of 20 centimeter. So u is equals to minus of 20 centimeter. This is a concave mirror, so maximum of the distances will be measured on the left side of the mirror, because in the right side we are not having anything over here. So the object distance is having the value of minus of 20 centimeter. Here the image distance is equals to how much? That is equals to minus of 10 centimeter. Now in this case we are just taking one of the example where I have just drawn a ray diagram. I know that that type of question will not be asked in your exam, but this is your first numerical, so that's why I have just drawn for the ease of your calculation. So in this case, what you can see that I have placed an object beyond of that center of curvature, and for that I am just getting the image in between of center of curvature and focus. So the image that is of small in size in this case, but we just have to calculate the image distance as it is not given over here. So we have to calculate the image distance. So what is given to us? That is the object distance is given to us, right? So the object distance, that is of minus of 20 centimeter. In this case, the focal length is also given, that is of minus of 8 centimeter. Why I am using this minus sign? Because all of the distances are measured on the left side of the mirror. So what we will use? We will use the mirror formula, that is of 1 by v plus of 1 by u equals to 1 by f, right? So 1 by v we have to determine. So it will be 1 by f minus of 1 by u. So 1 by f is equals to minus of 1 by 8 minus of 1 by u, that is of minus of 1 by 20. So this is the best thing that I do, that I use a bracket over here, otherwise there is a chance of mistake. So minus of 1 by 8 plus of 1 by 20, it is of 1 by v, that will remain same. So you are just getting what? So 20 and 8, that is of 40. So 8 5s are 40, 20 2s are 40. So 1 by v is having a value that is of minus of 3 by 40. So v is equals to how much? That is of minus of 40 by 3, right? Now in this case we are just able to calculate the image distance, that is having the value of minus of 40 by 3, that centimeter, right? So in this way you have to use the mirror formula to calculate the unknown value. In some of the questions, the object distance and the image distance will be given. You have to calculate the focal length. In some of the questions, the image distance and the focal length will be given. You have to calculate the object distance. So in different aspect, we have to use that mirror formula. So in that at the time of calculation, just remember one thing, that you have to use the brackets, because in the case of concave mirror, maximum of the quantities will be in minus. So you have to use the minus sign very carefully, thus you don't get any of the mistakes in the time of calculation. Now I'm just going to discuss the last case that I had told you that I will discuss. That when I am placing that object in between that of pole and focus, we are getting the image behind of that mirror. For that case, what the sign conventions that will be taken, that will be considered. Let's discuss. So now we are just going to discuss the last case where there was a concave mirror, and this is the principal axis, this is the pole, this is the focus, that's the center of curvature. You are placing that object in between that of focus and pole. So what that happen? A parallel beam of light that will travel and it will hit the reflecting surface and it will comes through that of focus. That means it will pass through that of focus. Another beam of light that will hit on the top aperture of that of mirror and it will pass through that of center of curvature. So in this case, the light diagram that should be straight, just remember. So in that case, the two lying after the reflection, in this case the two reflecting rays will not meet in any of the places. They will be just divergent in nature. So in that case, if they appears to meet at some point behind of that mirror, it will form a virtual image. So we are just going to discuss the sign convention. So that in this case the image distance should be measured like that. In this case the image distance should be measured like that. In this case the object distance should be measured like that. This is the object distance. In this case the focal length, that should be the focal length, and this will be the image distance. So for this special case, you are just placing that object in between of focus and pole. You are getting the image, it's a virtual image, and it is formed behind of that mirror. So for that case, the U that is become negative, the focal length that is become negative, but the image distance that is positive in this case, right? So that is the special case of concave mirror. That is a special case of concave mirror. Okay, so for that case the sign convention is something different with respect to all other the cases. That is all the 5 cases of concave mirror. We are just getting the sign conventions that all are negative, but for the last case we are just getting the sign conventions like that. So in the next class we will just proceed with more numericals about this concept of concave mirror and convex mirror. At this point of time I am just ending that class. So keep practicing, and if you having any of the doubts, just inform us on the given mail ID. Thank you so much.